everybody. Okay, today we're just going to talk a little bit about the basics of breadboarding and prototyping and how one makes use of a breadboard when they're trying to prototype a new product or design something. Now these are my two main breadboards. This is quite a large one that I use for bigger projects, and this is the one I use just for your everyday sort of smaller projects. I've done some modifications to this breadboard over here whereby I have a normal power input, my ground or earth, and then I've got a secondary power input which goes via a diode, which is sometimes handy on your power rails, and then of course spare, etc. The way I've wired this breadboard is the power rails connect to all of these, unless if I want to run like a secondary power rail, say for example on this rail over here, then I can pull the positive out and we still maintain a common ground, which is quite useful, especially when working with Arduinos and microcontrollers and such. So this is your first requisite when getting involved with breadboarding. The next thing we need to definitely make sure that we have enough of is of course components. I have a box of components with mixed bits and pieces that I use for my breadboarding, various capacitors, resistors, transistors, etc. Sort of general betrayer stuff. There's some more little bits and bobs, LEDs, etc. over there. Then of course these connectors are important. Different shapes, colors, sizes, lengths, etc. These are basically little pins, I don't know if you can see them too well over there, which are used for example, if we wanted to power from here to something that was over there, you just basically push them into the holes in the breadboard. So this is your connecting wires basically. Have a nice assortment of those. You can sort them however you like. I don't really worry about that too much. Then the next important thing with breadboarding, components. I have trays and trays and trays of prototyping components, whether it be these guys over here. This is 2 trays of resistors. Inside here we have the resistors all sorted into various packets, every value known to man. Well, not every value, but 90% of them. Then over here, what else do we have over here? Let's have a look, see. Just digging in the boxes over here because we've got tons of them next to the workbench. Then over here we have some more prototyping bits and pieces. We have our LCD panel with pins for pushing directly into the breadboard. We have a keypad, also pins soldered on for plugging straight into the breadboard. Different type of LCD. We have a little servo motor down here. We have this is a USB programmer for the Arduino minis, such as this one over here. I prefer to use these in projects because they do cost a bit less and less overhead on hardware. Some more LEDs. This is an adapter for the ISP AVR. So you basically plug that there into your Arduino board, and then you plug your ISP AVR, such as this one over here, into that, and you can program the AVR directly or burn bootloaders, whatever you need to do. There's so many options with those. Got a couple of ICs in over here, some logic gates, etc. At the bottom we have a few more little boards, etc. Spare AVR, motor controller, another motor controller. Like I say, a lot of my components are not in here at the moment, such as my Arduino. And yeah, that's some more prototyping bits and pieces. Finally, we have another box or another tray with variable resistors, crystals, audio transformers, various diodes, transistors, LEDs. This side over here is mostly transistors and MOSFETs. Over here we have voltage regulators, capacitors. So yeah, pretty much get yourself a nice assortment of parts for prototyping, and you won't go wrong with that. The nice thing about breadboarding is it is solderless, so you don't have to necessarily solder all the time when you're trying to do just a basic experiment. And as far as connecting up, you literally run your leads from your ground to your positive point, to your power supply, set your voltage, and your voltage is railed wide. Then on this breadboard over here, it's very similar. Unfortunately, I haven't connected up these power pins to anything. They're just kind of there. This is more a Chinese DIY sort of breadboard. The idea being though is that you could maybe connect in over here and then power this out to multiple rails on the board. A little bit of a different layout, not as simple to pin out as this one over here, but still a very useful piece of kit. So that pretty much covers the basic requirements needed for starting to breadboard your projects and testing. Breadboarding can be a lot of fun when you get used to the layouts of the breadboards. Just for those of you out there that don't know, these red and blue lines over here, they run from all the way from there all the way across down to the bottom. So the red line, blue line. So those are power rails. These other points over here run across. So this will go there, 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 there. So pretty much what will happen is there's no interconnectivity this way unless you jumper it. The connectivity is this way with a break in the middle this way. And then you've obviously got multiple points where you can place your components. This breadboard, pretty much the same sort of layout, just a different quality of breadboard. So I suggest you get yourself a nice breadboard, a nice multimeter, and some little plug-in leads, a bit of a component selection, and then you can start putting the projects together that you see online on Google, etc., and trying them out before you actually build them onto PC board, etc. Like I say, I design on computer. After the design is implemented and tested in computer software or simulated, I breadboard it. Once I've breadboarded it and it is physically working, or I make changes to the design once it's breadboarded because I see some sort of a failure point or possible failure point or issue, I correct it in the breadboard design, finalize it back in the computer, and only then do I start doing PC board layouts to send through to the PC board manufacturers to make my PC boards for me. Breadboards have to have, if you want to get into electronics prototyping, guys, have to have. Anyway, that's just a brief introduction to breadboarding, so let's move on with the rest of the episode. Hey YouTube, welcome to this next installment of the Evian blog. It's not really the next installment. This is a bit of a continuation of our soldering tutorial. What we're going to do is we're going to get a look at the different solders, different soldering irons that you can get, and the different tools that I think are recommended when it comes to soldering. Obviously, you get different types of soldering irons designed for very specific tasks, but for general electronics work, I'm going to cover the basic irons. Temperature controlled is a must if you want to do a good job. But before we get into that, let's have a look at the basics of soldering. So what's needed when you're doing soldering? The first thing, of course, is an iron. Over here, we have this is a Solomon SL20 iron. It is a 25 watt temperature controlled electronic soldering iron with a fairly small tip. Pretty good for sort of everyday general electronic soldering. They do come highly recommended. I do have some video which I'll overlay now as I'm talking, showing you the MNR 8520, which is a micro soldering iron as well as a reflow station or hot air reflow station. And then of course you get small little irons for fine SMD work, like this little guy over here. Fantastic for doing SMD soldering. This thing really, just to give you an idea, is very small. Very handy piece of kit to have. It's also a must. Another must with soldering is when you're removing components, you need something called a solder sucker, like this over here. Those of you that know me do know that I have a desoldering station which does the same sort of job, but learn to use one of these. Trust me, 90% of the time I don't even bother turning on the soldering station. I just pull one of these out with my iron, get the component out, get the new components in, and Bob's your uncle. Why wait for another iron to warm up when you already have one warm on the bench? Then, of course, you get your solder. The solder that I use, I have two different types that I use very commonly. The one is a 0.7 millimeter. The 0.7 millimeter is a 60-40 solder. Very good for general soldering. Nice if you want to reflow bigger components, transistors, etc. Then the other one that I use is a fluxed wire. This is a 6337. Much finer solder than the 0.7, as this is a 0.5 mil. That's about as small as I bother to go. You do get smaller, but I just don't see the need when that is quite fine as it is. Then, of course, there's little things which do come in handy when you're soldering, such as helping hands, etc. Also very, very, very nice to have, help you get the job done easier, etc. A few other things that I can recommend are a flux pen or a bottle of flux of some sort. And of course, very important with soldering, your sponge, which sits on top of your soldering station, or however your soldering station works, you normally have access to the sponge. Keep it wet. It'll keep your tip clean of your soldering iron, and of course the soldering goes a whole lot easier. Let's take a look at some actual soldering and see what it's all about to get into some through hole and some surface mount soldering. Let's go. Right, what we have over here is my one soldering station, used mostly for SMD work. It has a very fine sort of soldering iron. The sponge that I spoke to you guys about keeping wet is over there. And then of course it has the hot air blower portion of it as well. Quite simply, you can use the soldering iron. I have this one set at 260. Once it's warm, this thing will flash off and then it'll be ready to use. There we go, it's warming up. As you can see, this iron heats up really quickly. We're at 104, 121, 140, and it'll basically get to temperature. On the camera you might be seeing some flicking over here, but in reality it's actually just the refresh of the LED display. It is constant. There we go, we're at 260 degrees soldering temperature. The hot air station works very similarly. You set your temperature the moment it's in standby because it's on the cradle. When you pick it up, you'll hear the pump come on, and of course you'll see the temperature start rising. So it's at temperature. When you're done, put it back in there. It'll start cooling down, and when it gets back to zero, it'll turn the pump off. The reason for that is so that the element doesn't overheat. So yeah, that pretty much keeps things running nicely. You can set your airflow. You can set your temperature on your heaters on both irons individually. So this is quite a nice all-round sort of soldering station. Let's go and have a look at the other ones that I make use of. Here we have the Solomon SL20. This is the one that I showed you in the intro video. Quite a nice size iron, again with the soldering sponge over here. This one works where you turn it on, you preset this to the sort of temperature level you want, and then the LEDs show you what the actual temperature is of the iron, so you can see when it's at operating temperature. Over here we have the upgrade on the SL20, which is the SL30. This one, when you turn it on, you've got your set temperature, where you can set what temperature you want the iron to be at, and then your read temperature. So you can see what the current temperature is, as well as the heater on, LED, etc. It uses the same actual iron as the SL20, just the controller base is a bit different. Very versatile as well, very commonly used here in South Africa, and worth absolutely every cent. This one that I have, the SL30, was actually a throwout iron, which I've restored and brought back to its former glory. Quite love using it. It's very often used on my bench. Now let's move over to the last type of soldering iron, which is the fixed cable or non-temperature controlled soldering irons. The last kind of soldering iron, but least recommended, is one of these, where you just have your plug in your actual iron. This is a larger one. The only reason I have it is for soldering large sort of conductors and stuff like that without damaging my fine irons. This is a 60 watt iron. You do get them smaller, 25, 15 watts, etc. I don't recommend them because you don't have any control over the temperature. But of course, if you cannot afford or cannot find a temperature controlled iron, then of course this would be your only way out, in which case go ahead and get yourself one. After all, you cannot solder without a soldering iron, unless you want to try and use a lighter, but that could be a disaster, trust me. Then another kind of soldering iron is these over here, which connects to a USB port. Problem with these is they do draw quite a bit of current. This one draws around 1.5 amps, so you can't actually plug them into just about any USB port. I use it off a 5-volt power pack, so it makes it portable. Then just one more iron I want to show you guys. Is the gas type soldering iron. I use this for heat shrinking and of course for soldering on location. It keeps things portable. They are a little bit hotter than need be, but you can set the temperature on these. And a very, very useful piece of kit if you're working out in the field quite often. So guys, they are pretty much showing you the basic soldering irons, the types you can get, as well as the very basic tools that are needed for soldering. So let's get into actually doing some soldering. Okay guys, so I'm just going to get a little bit into the actual soldering. This is just an LCD generic board lying around. But what I'm trying to show you guys over here is, let's say for example this was the back end of the board and we were placing this resistor over here into said board. The soldering, how one would actually go about doing that. Now the way I like to do things is pretty simple, is I basically place the component through the through hole. I'm starting with basic through hole soldering obviously. We'll move on to surface mount in later tutorials. Then I use a clipping tweezer which locks to hold it in place, so I pretty much clip it on like so, and then I can place it like so, giving me access to the leads. Now with soldering, it's not so much about the way you do it, it's more about the basic principle of how to get something soldered. Now you bring your soldering iron in, a lot of people would try and jam the solder and soldering iron and then try and get the joint to solder. The easiest and simplest way I've found is the first thing you do is you wet your iron tip a little bit with solder, okay, then you place that onto the point, give it a second or two, and then you flow solder into that joint like so. Done. Perfect solder joint. The other side, the same thing applies. You can either spin it around or you can actually take the clip off here now because it should be sort of stuck in place. Make sure the tip's a little bit wet with solder. Place it on the joint, give it a second to heat the joint, and flow solder into the joint. Just like that. Done. Now, a lot of people believe in using a little bit of heat. I believe in a little bit more. I mean, I run between 250 and 300 degrees on my average solder point. Another thing when it comes to soldering through hole that you need to get yourself is a pair of these for cutting off excess lead. Just like that. Done. So there you have a perfectly soldered through hole joint. Not that it's actually going to do anything there, but it was just for the purpose of showing you guys. Components soldered into place. Happy days. Now I'm going to record some microscope footage of these solder joints so you can see how they flowed nicely in and how everything is seated quite nicely in there. Okay, so that's your basic through hole soldering done. But now what happens when you need to unsolder a component from the board? Things get a little bit trickier at that point because now you kind of have to remove the solder without overheating any of the components. So the simplest way of getting the job done again is your soldering iron. And as I've mentioned before in the beginning of this video, you need to get yourself a solder sucker or solder vacuum, which is great for sucking up any of the solder on the joint. So your temperature of your iron, depending on what you're heating, it varies. At the moment I have my iron sitting at around 250 degrees. Again, I believe fully in wetting and cleaning the tip on your sponge, on your wet sponge, and then you just basically wet the tip with solder a little bit, which will also apply some flux to it. We need to remove the same resistor, so you just heat it up, pop the iron on there, heat it up, and suck the solder off. Now the same would go for the second joint. Heat it up, pop the solder off. Now if you've done this right, it does take a bit of practice in the beginning. Then the components should literally just slip out of the board without any sort of battle or hassle. Sometimes it might still be a little bit tacked on, if you want to call it that, in which case you can either just grab a little pliers or something and just jiggle it loose, or you can just touch it again with the iron and that will loosen up any sort of extra soldering. No worries, no problems at all. Done. And you have your clean holes for your new component to go in. No damage to the resistor that you've unsoldered, everything perfectly intact. So yeah, it keeps it nice and simple. That's your desoldering technique. Board still looks pretty good, no damage. The biggest trick with any soldering is getting in and out quickly. You don't want to be sitting on these joints for extended periods of times, because then you start burning and lifting tracks and pads, etc., which is no good for your soldering quality. So this is just something to keep in mind for those of you that are just starting out with soldering techniques and how to solder. Higher temperature, get in and out as quick as possible. Don't linger. If you linger on the joint, you're going to cause some damage. So let's move on and do some actual soldering on a PC board where there's a component that needs to be replaced. Now, bearing in mind, I would usually use my desoldering station for a lot of this. Sometimes I use the solder sucker, but the desoldering station, not everybody out there has them, hence why I'm not using them, because it's kind of like saying go out and buy one. I'm not saying that a lot can be done with just your basic solder sucker. Right, so we're just going to remove a IC here using a hot air station. The simplest way is just to apply some heat to both sides. Simply running it over and there we go. You just basically run the heat over until the chip falls off, and it's quite simply, that's how you remove an SMD component. Guys, just so you know, I was using standard 60-40 solder over there. I'm not going to go into all the consistencies of solder, but 60-40 or 63-37 will be fine for most of you out there that are just getting into soldering or wanting to learn how to solder, or for those of you that are actually watching this, I would assume you haven't had too much experience with solder and such. So 60-40, 63-37 should be fine. Both are pretty good solders for general purpose electronics use. A few other things to note, however, is when it comes to soldering, the few things that need a bit of practice are the amount of time you spend on the pad, because you want to spend as little time as possible on the pad. We must remember with soldering, it's not about melting the solder. It's purely about heating the two components that you're trying to solder together, A being the pad and B being the leg of the component or the pad of the component. So you need to heat those up hot enough that the solder can flow onto those surfaces without any problems. So it's not about melting the solder, it's just about getting the points that you're wanting to solder together hot enough that the solder can flow into that point and basically solder or join, braze, weld, whatever you like to call it, those two joints together so that you have a good joint. If you're worried too much about melting the solder, you're going to end up with dry joints because your solder is going to melt, it's going to drop onto place, the pad isn't hot, so it's not going to flow into the pad, it's not going to flow onto the component leg, etc. So you're not going to get a good joint. Practice makes perfect with any of these sort of things. We're going to skip the soldering for the next few episodes, get on with a few of our other projects, and we will be back with the basic SMD component soldering in the not too distant future, guys. Take care out there, and until next time, have a fantastic weekend.